for that poll, and then we'll close her up. All right, fantastic. Thank you guys for that. Let's just jump into the good stuff then, shall we? Yeah, so welcome back to session number 3. Session number 1 and 2, hope you guys been enjoying so far. Session number 3 is going to be jumping into kind of the meat of things, I would say. It's really what separates a boring calculator from a computer, if you ask me. And this is the part where like games suddenly becomes all the more feasible. But first things first, I'm just going to talk about some applications of software out there. As usual, just a reminder that we are recording. But other than that, in the world of our modern technology here, how many of you guys have rode inside a car that could drive itself? So Tesla being the #1 example here, but there should be some other ones out there. How many of you guys have actually been in a car like that? I wish. I know, right? Okay, so there's still up and coming technologies, but I think that in my opinion, it's not exactly on the commonplace on the market yet, but they're definitely showing up, and it is becoming something that I believe is incredibly awesome to find yourself in the position of as a software developer or as just a consumer of the software environment. I mean, it doesn't take any surprises here to understand that artificial intelligence uses a whole bunch of different things like sensors, actuators, complex algorithms, and machine learning, heck of a lot of AI, and a lot of computer power to go and run these things. We got a bunch of things like radar sensors and video cameras to go and like automatically detect and make decisions about like where is the lane, where are the cars, where are the pedestrians crossing the road and stuff like that. And we got a bunch of other things as well, like LiDAR detectors and ultrasonic detectors as well. And the machine learning behind the scenes is some incredibly powerful stuff that a team of engineers have made to make the ultimate decision-making machine, which I think honestly makes a beautiful segue for me to talk about our scope today, or our session today, because we're going to be talking a lot about Booleans and the much more common terminology, the if and else statements. But before we do that, let's go and have a quick chat about scope, because I knew this was a complicated topic from the previous session. So scope, just a quick reminder of how this works. I was telling you guys that there was the def setup and the def draw chunks, and they're kind of their own isolated chunks. They're kind of analogous to countries in their own kind of strange way. And the laws stay inside countries, just like how variables stay inside scope, and variables don't last outside of there. So if you want to go and get a variable that lasts forever, we got to have this thing called global variables, and we use a global keyword to access that. So when we're going to go and try getting a ball that can go and slowly inch its way across the screen, we can't just simply say X is defined as 10 inside draw. Now, what we do is instead we put it near the top of our code. We say X is set to 10 up here, create a global variable. And then down here, we will say global X, create or get access to that global X variable within our draw function. Down here, we're going to start using it, changing it, applying it, etc. And this X here does not get destroyed every time. It will stick around. So 10 changes to 11, and then you print 11. And then you keep it. Go into here again, grab that 11, bump it up to 12, and then you keep it. Bump it up to 13, and then you keep it, and you keep on using it. So very powerful concept here, and it'll be pretty darn helpful if we can keep track of that. Anyway, I'm going to go and jump into something called Booleans. It's a pretty darn fancy word for something unbelievably simple. It is basically any true-false test you have ever written in class is basically something to do with Booleans. Booleans is just another type of variable. I've talked about variable types before. I talked about strings, I've talked about floats, and I talked about integers. I'm now going to talk about Booleans, which is another one of the very common ones. And they're incredibly simple, despite the strange name. They are only true or false. And you can probably understand that in the computer language, that closely ties to the idea of like yes or no, 1 or 0, these kind of concepts that the whole computer runs on, the whole binary system there. And they're very, very powerful for when we start talking about if statements down the road, because they really give us a good framework to go and describe simple yes or no questions. So let me go and show you the syntax examples here. So how many of you guys, are you in high school? I'm assuming that 99.9% of y'all are actually in high school here. So yes, that statement is true. And we're gonna have that capitalized T right here. How about, is it summertime? Whoops. Oh, wow. I realize these slides are terribly out of date. Yes, it is summertime, but we have designed these slides for back when it was wintertime and freezing cold out there. So I'll go and ask you guys a different question then. Tell me, is this statement true or false? Today is Halloween, true or false? False. All right, perfect. Fantastic. See, super easy. You guys all understand that. It is just a simple true or false. Do pay attention. I do want you guys to remember that whenever you type out true or false, you do need a capitalized T or do need a capitalized F. I know that your variables typically stay lowercase, but Python does have some special rules about special keywords just like this. And in the meanwhile, we got some other ways to go and quantify things here. And this kind of goes down to some very, very basic math operations here. So you got the less than operator, the greater than operator. You have lesser than or equal to, or greater than or equal to. And then we also have some other ones here, which these ones are actually incredibly simple, despite looking weird, is the double equal sign. Do you remember last time how I was telling you that the single equal sign is not actually equal? It is the set to, it's the assignment operator. Well, the double equal sign is the actual equal sign, which is a little bit weird to hear. But yeah, it's absolutely true. And I'm going to go and quickly demonstrate that for you. So I'm going to ask you, 2 plus 2 is equal to 4. Is this statement true or false? Perfect. Yes, exactly. Pretty darn simple that 2 plus 2 is 4 on here. And then naturally, by extension here, you guys should be able to quickly figure out this one. 2 plus 2 is equal to 5. True or false? Perfect. Easy stuff here. I can't trick you guys. And I got one other operator. I'm just going to go and mention it here because we do use it occasionally. We also have the not equals operator. It basically says go in and flip it on its head. 2 plus 2 is equal to 5. This is clearly false. If you want to use the not equal, which is basically this statement, it would be saying 2 plus 2 is not equal to 5. How about this one? Is this one true or false? All right then. Precisely, 2 plus 2 is not equal to 5. 2 plus 2 is not equal to 5. This is true. So we can see that this is actually pretty darn simple to go and think about. You guys can go and evaluate these things really quickly. And the powerful thing about this is that computers can go and evaluate these things too. We can go and assign these things into some variables so that we can actually go and start comparing these things. Or let me start with a simpler example, print. And I'm going to say print 2 plus 2 is equal to 4. And then let's just go and see the computer. When I run that thing, it says true. Absolutely, obviously true. We can try our next one. 2 plus 2 is equal to 5. And it says, nope, that is false. And then you can, of course, go and say 2 plus 2 is not equal to 5. And then this one is going to be true again. And we can go and do something else. I can extract the statements here. I said any number can be a variable in the past. I also want to say that a lot of other things can easily be transformed into variables. For example, I'm just going to yank this out and say 2, or is this true? I can go and pump a statement right here. And I can go and basically make any Boolean test right here. So I can say 2 plus 2 is equal to 4. And that says, is this true? Is set to the value of this thing here on the right side. So I can print this out. Is this true? And I can go and, yep, this would be saying true. It's the same value as last time. Let me show you one more example here just before we move on. Let me just go pump these out just so it doesn't distract us. And how about we go and say, let's say, should bring umbrella? And we'll say this should bring umbrella. This is only true if it is raining outside. Should bring umbrella if it's raining. So we can go and say, is raining outside? We'll set this to be true. And we should say should bring umbrella. I'm going to set that to be equal to is raining outside. Print should bring umbrella. Any guesses what this code is going to give us before I press that run button? Perfect. You guys are too good at this. And yep, it doesn't even change before because it's just the exact same thing we were printing out as before. We can go and use Booleans to go and, yep, the Boolean is basically these expressions here on the right side. And you can go and just use the left side to store that as a variable name. You can also say it's like, is freezing outside is if, is true, if we can say the temperature, let's just say it's an arbitrary -10, is lesser than 0 degrees Celsius. So this is just another way of expressing these statements here. I think that this is an incredibly simple concept, and you guys will be able to appreciate how valuable it is when we go and jump into the further slides here. So we got another thing, because we can go and start combining these things together to make some more complicated statements. So for example, here, I got a couple of them listed on the screen here. I got statement number 1, programming is fun. Is that true or false? Yep, perfect. Thank you for that. Okay, programming is fun and programming is useful. Is programming useful? I'm going to say yes, because it is, obviously. And we are going to be able to say that since both programming is true, programming is fun, and programming is useful, we could say the entire statement is true. We can go and take a look at another example of like that and statement here. We can say there's Halloween has candy and Halloween has Easter eggs. Well, the Halloween has candy. Yeah, that's very true. But Halloween does not have Easter eggs. So in total, this statement, Halloween has candy and Halloween has Easter eggs, nah, that's going to be wrong here. But then we have one more word. We have the or statement instead that we can revise this out. So we could say Halloween has candy. Yeah, that's true. Or Halloween has Easter eggs. No, that's not true. But together, when we look at this, Halloween has candy or Halloween has Easter eggs, well, one of them is true. So yeah, we'll say this entire statement is true. These and statements and or statements get combined together to go and make much bigger Booleans, which would be quite useful in a couple of examples later down the road. For example, controlling your mouse X and mouse Y coordinates. That's one primer I'll put inside your heads. And so I showed you the and. In Python, you type out all lowercase. Someone asked me why you choose lowercase here and uppercase elsewhere. You choose and is going to be lowercase. You got or is going to be lowercase. And we got not as well. Not is a pretty simple one. I'm not going to spend too much time on it because it's just basically equivalent to the not equal sign we saw. So you say, take a Boolean, flip it on its head. 6 is lesser than 3. Well, that's never true. So that's going to be false. But 6 is not 6 is lesser than 3. That is true. You do have to go and stare at that thing closely to wrap your head around it sometimes. Anyway, I'll leave this for your reference for your reading if you ever need it. But these are pretty darn simple and you can learn them pretty darn quickly. So I'm going to go and jump into the fun stuff now, if statements. I'm just checking, making sure I am still on my scheduled time here. Fantastic. So if statements really comes to go and bring like life into a computer here, because previously we had a calculator, a glorified calculator that basically you punch in some numbers and gives you out a number. But a computer, the magic of that is that it's smart. It can make decisions. It can make things happen based on what inputs it is given. Based on what conditions it is given, it will make actions happen. So back to my umbrella example here. I can go and I'll just type this out straight into the Zoom chat here. If it is raining outside, then I want to bring my umbrella. And it seems like a pretty darn straightforward idea. If something is true or not, then do some action based on whether or not that is true. And so let's go and show an example of the temperature in the furnace here. Let's just say I'd like to go and keep my temperature right in the middle here. So I'm just going to wipe out this existing code. I'll start fresh with some new code here. And let's go and say, let's see, house temperature. Let me go and start with house temperature. And we're going to be talking in Celsius because we're civilized people here. And let's go and say it is a really, really nippy cold 14 degrees inside the house here. And I'm going to say if house temp, is lesser than 20 degrees, colon, and I'm going to press enter on that, and I'm going to print, turn on the furnace. So we have a piece of code here that only executes if this statement is true. Let's go and trigger that on. Turn on the furnace, please. I'm a little bit cold. And we can see what happens. We go and change the temperature. Let's go and set it to toasty 23 degrees, and then we go and run that again. And yeah, we don't run this code because naturally the temperature is already done. We can also add a second if statement down here. So I would like to just quickly show you guys. I press enter. You notice how there's some spaces here. That's the code that lives inside the if statement. If I press enter and if I press backspace, I'm going to unindent. So I'm going to say run this code no matter what happens. We're outside of the if statement. And you know what? That's convenient because I want to type out another if statement. If the house temperature is greater than 25 degrees, because it's now swelteringly hot in here, we can go and print, turn on the air conditioning because it's too hot now. So when the temperature rises up, let's go and say, oh boy, it's a scorcher of 27 degrees. You take a look at this first if statement. Is the temperature less than 20 degrees? No, it's not. It's greater than 20 degrees. This conditional is false. We're going to skip it. This conditional, though, if the house temperature is greater than 25 degrees, is 27 greater than 25? Yes, absolutely. Then yes, let's go and turn on the air conditioning. So I believe that like if statements are such a natural, intuitive idea here. And it's only just a matter of learning how to go and plug in some syntax, memorizing where those colons fit in. But otherwise, I think you guys already are naturals at if statements. And it's pretty darn cool, the fun things that we can go and do with this. Let me go and show you by just simply tapping out some code here and understanding why this slide is not showing up here. Basically, I'm going to have inside my draw statements here, I'll just draw a quick little line right down the middle of my screen. And I'll say, if my mouse is on the left side of the screen, go and do something different than if it's on the right side. So wipe that out, and I'm going to do from processing imports. Import star. I'll type in the run thing, and then we'll just do the usual def setup. Size 500, 500. Def draw colon. I'm going to go and set myself a background. Let's just use a grayscale background of 200. Make sure that this works first. Okay, we got a lovely gray boring background. So what we're going to go and do now, I draw a line and we'll put this thing straight in the center here. So I'm going to go 250 pixels to the right and then 0 pixels downwards. And then I want that thing to be 250 pixels to the right. And I want it to be 500 pixels downwards. We go and run that real quick. And there we go. We got a beautiful line straight in the middle of our screen here. And then I'm going to go if mouse X is, let me be consistent with what I typed out, less than 250, then what I want to do is fill, so with a nice red here, set to red, and then I'm going to draw myself an ellipse at mouse X, mouse X, mouse Y, and we're going to go with, well, let's go with 50, 50. And when we run this code, we can see a live example that you can play with right now. Is that I got myself a mouse. It's on the left side here, which is less than 250. Take it over to the right side, greater than 250. Does not run the code. Left side runs this code. Right side does not run this code. And it's pretty powerful when you get to go and show off all these fun little toys here. I'm going to go and also compliment that there is a counterpart to the if statement called the else statement. The else statement is a very, very natural thought as well, saying that like, hey, if it's not true, I want to go do something else instead. So a pretty simple example here is that, well, when we have a human driver behind the car or if we have a human person and they're getting themselves a nice phone call and we got to go and ask, hey, are you driving? If yes, we're going to do our regular if statement stuff. We're going to send a call to voicemail because we're all good people. We don't talk while we're driving. But if we're not driving, if we go down this no route, then hey, let's go pick up the phone. Let's have a quick conversation on here. So you can see that the else statement complements it pretty darn nicely. And I want to go and show you something really quick with the way that those brackets work, or sorry, that indenting works and everything. So order of execution does matter a lot in here. I'm going to go and keep on elaborating on my existing example here. What I want to go and show you guys is what happens if I take this ellipse statement and I just pop it down here. So what this code's going to do now, this ellipse is no longer part of the if family. It's going to draw no matter what. So we can see it's drawing no matter what. Let's pop in an else statement over here, else, colon, and let's say we want something else. Fill, let's go and set this link to be blue, set to blue. And we can see now, oops, we got red, we got blue, red, blue. But the important part I want to pay attention to is A, we got the else statement, which is indented just like the if statement is. And then we also have a piece of code that runs after, no matter what happens. If it's true or false, you're going to run this code either way because it comes after the if statement. It's not part of that block anymore. And I think if I want to go and show off something a little bit more cool, rather than just simply showing off any lit or a set of fill here, let me go take this statement. I'm going to go copy that with Control C. I'm going to remove it here. I'll put it back where I originally found it. And I'll go and also paste it right here. But I'm going to just do something cheeky with it. I'm going to say, instead of just drawing it at the mouse X coordinate, I'm going to draw it at 500 minus the mouse X coordinates. And what that does, it gives us a really cool effect of being able to draw a mirror image as soon as your mouse crosses over the border, which is pretty darn awesome if you ask me. You can get some really cool stuff if you know how to go and manipulate your if statements, else statements, and you know how to do a little bit of those transformation maths that you learned back in grade 11. For those of you who aren't there yet, don't you sweat about it. We're not here to test you on math skills. We're here to have a good time with some cool stuff. Okay. With that, before I show off the quick question, are there any questions for me? How are people feeling about this? Okay. I'm assuming nobody is typing still, so I will just carry on, which is fantastic because I get to flip it over to you guys. This quick question here. Suppose that my mouse X is 100. So that's right where the ball is right now. I want you guys to go and tell me, what's the background going to be? And what's the fill going to be? What colors are we going to see? Let's go.
Okay, we'll have 30 more seconds. All right, I'll go ahead and close the poll. And then we'll.
All right.
And then
How did
78% did choose the correct answer, which is option B.
Fantastic. So I think a grand majority of you guys are getting this one, which is, thank goodness, you guys are paying attention to subtle little details here, including, I bet you that the one thing that tripped up a few of you guys here is that this fill statement at the very end, look at that. It is not indented. It is not part of that if or else statement family. Instead, we see that it's part of that code that belongs after the if statement. So the if statement says, if the mouse is on the greater than 250, then we're going to set the background to red. Is the mouse greater than 250? No, it's not. It's lesser than that. So we're not going to do that. We're going to instead go into the else statement. It says set the background to 255, which is going to be blue. Just reading that off on here. So we're going to use the blue background. That seems to be clear enough. And then it says also use the green back or the green fill. But oh ho ho, what is this? This little line here says run this code regardless of what happens and says reset that fill color to be yellow. So the correct answer is going to be blue as a background and yellow as a fill. So congratulations to you guys who've managed to get this question. And now I think I actually have extra time for a change, which is a miracle. So I'm going to say, let's take 15 minutes. What I want you to go and take a look at is how do we get this ball to go and travel along, which hopefully you guys remember how to get a ball to move to the right. And then when it hits the end here, make it boop, teleport back to the beginning and move all over again. So what I want you guys to go and think about here is what spot do we want the ball to go and teleport? And another question here is where can we apply the large if statements here? What should we be testing? Let's take 15 minutes to go and figure that out. Nice, nice. Okay, that's great to hear. Getting lots of yeses, that is very reassuring to hear. And how many of you guys were also able to get the ball to go and teleport back to the beginning when you're done? Almost got there. Sounding good, sounding good. That's fantastic to hear. It sounds like a lot of you guys were doing pretty darn good on this exercise. Let's recap it real quick for the people who are just wrapping up. So I think that you guys are all pretty comfortable with the idea of getting this ball to go and march across the screen here. And now the part was, how do you get an if statement to go and check when it runs off the edge of the screen? Well, the easy way to go and manage that is you say if the ball is hitting the end of the screen. And now we just need to start translating these concepts into actual code. If ball runs off edge of screen, then put it back at the beginning. And when we translate this back into real code, we can start saying that the edge of the screen, this is talking about the x being greater than 500. And when we say we're talking about putting it back at the beginning here, we're saying x is set to the value of 0. So what that looks like in code is if x is greater than 500, colon, then x is going to be set to 0. And let's go and run that real quick. And we got that ball marching ever so slowly across the screen here. And poof, there it goes. That's how you get it to go back to the beginning. And of course, I can actually go and bump it up to be a little bit faster and all. And I can go x is like 3, and then we should see it popping back and making full loops a lot faster. And I'm going to go and say, if you are noticing, some of you guys tried if x is exactly equal to 500 versus if x is greater than 500. And if you try this, there's an actual rather curious detail. It doesn't teleport back to the beginning of the screen here. I'm not going to answer why that is. I'm going to leave that as a little thought exercise on, hey, should I be using the greater than sign or should I be using the equals sign? Why did the equals one fail for when I have my speed set to 3? I'll leave that as an exercise for you guys to think about just in the back of your heads. Nothing to be focusing on right now, though. Okay, I got a couple more topics to wrap through, and then we got some more work time to talk. So we learned the if statements, we learned the else statements. We got this one more called elif, which I always think is a really funny word, but it is just simply a shorthand way of saying else if. And the way that we work with elif or else if is that it goes and helps break it down into multiple chunks in case if you want to do more than 2 actions. If action number 1, else action number 2. What if you want to do an action number 3 based on they've been, I don't know, some maybe in between values. So that's what elif is for. Else if you want to expand it to its full wording. So a great example here is like, maybe I don't feel too good about this. And we can go and talk about like, hey, let's say you want to go and try buying something in the store and you realize the price is $33. And let's go and take a look. If the price is greater than $40, then we would go down this left arrow and we say, that's too expensive. Else if we go down 1 arrow and we go and try, the price is greater than $30, we're going to say, hey, that's not bad. It's a good deal. And then if it fails that one too, let's say if the price is even lower, it goes else. And you can say, hey, that's a great deal. It's fantastic. And one other detail to note, just not really shown on these slides here, is that you can chain together these elif statements. So I am going to just go and open up a brand new trinkets because this is getting a little too crowded for me to read. And so we can go basically say price is equal to $33. And I say if price is greater than 40, we'd say print too expensive. And then I can show you that you can actually chain together multiple elif statements. I wanted to show that real quick. Elif price is greater than 35, it prints little pricey. And then you can go and keep on adding in more. Elif price is greater than 30, you can say print good deal. Elif price is greater than 25, it prints wow. And then else prints is this for free? And you can notice that you basically get tiers of these else if statements going down. And it's just basically a waterfall cascading of elif, 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 and you keep on checking them until one of them come true. So in this case of 33, you check 40, nah, too expensive. 35, nah, it's not falling in there either. But it is over $30 now. And that's when you go and say it's a good deal. That's what I wanted to mention about chaining it, which luckily I don't think we need to worry about too often. Another cool thing, I'm not going to dive into too much detail on this one. This one's just a fun exercise to read, is that you can also go and combine together multiple statements. So you can plug in the not keyword and with the ands and the or statements as well. So if you like green eggs and hams, or green eggs and you like ham, then you can go and print out that you like green eggs and ham. If you do not like green eggs and you do not like ham, print I do not like green eggs and ham. I do not like them. Sam, I am. And on that note here, let's just go and bring it all together. And let's go and talk about a bigger example. Don't worry about that elif statement just yet. We're going to go and build up to that. And I just want to show that you can actually get some pretty cool effects about using the and statements. So we were talking about the else statement or the elif statements earlier. We're now talking about the and statements. Okay, this one looks like it's fast for me to edit. So I'm going to go and say, I don't need this X variable anymore. So I'm just going to wipe out all the code we don't need. Okay. So what we're going to do is say that we always want to draw an ellipse at the mouse coordinates, no matter what we're doing. Mouse X, mouse Y, 50, 50. And then that's just some basic stuff here. And now, if we want to go and set the color of it, set the color based on the quadrants. We want to say, if it's in the bottom right, then we're going to go and change its color. So as long as I remember what my slide said exactly, it's going to be setting it to green. So if the mouse X is greater than 250, oops, no colon there, and mouse Y is greater than 250, then what we are going to do with this is set it to green. Fill 0, 0, 255 and set to green. And then else, if you are in any other quadrants because your mouse's X is too small or your mouse Y is too small, then we would just set it with blue instead. Fill. Oh, wow, I just realized I mixed this up. This is RGB, so this should be 5. Ignore that little detail. I'm just terrible at memorizing these links. Otherwise, we're going to go and fill it with 00255. Set to blue. And when we run this, we now have a blue ball here when it is lesser than 2, or when mouse X is lesser than 250, or lesser than, mouse Y is lesser than 250. Down here, only one of them's working. Over here, only one of these are qualifying, but not both. Finally, when we're down here in this bottom quadrants, both of these trigger at once. So I think that that's pretty cool, because with that, we can also go and add in a little bit more. I'm going to challenge you guys here. Take a look over this, read it over, and tell me what color is the circle going to be. 1 minute, chop, chop. Okay, we should be wrapping up pretty darn soon.
Just 20 more seconds and then we'll close the poll.
Perfect.
Okay, I'm just going to end it, and green is 67%, and I think that is the correct answer as well.
Okay, fantastic. For those of you guys who got it, excellent work. And let's go read over real quickly why. So these coordinates are a little different. It's not the 250 that we've been using this entire time, but hopefully you guys were able to read it all the same. When the mouse x is greater than 150, so we read this over. If mouse x is greater than 100, yes, that's true. And mouse y is greater than 100. Ooh, 50 is not greater than 150. And so this and statement means no. They're not both true. So we are going to say this entire condition is false. It's not going to be read. If we say mouse x is less than 100 or mouse y is less than 100. Let's read. Mouse x is less than 100. Well, 150 is not less than 100. So that's false. Or mouse y is less than 100. Ooh, that is true though, because we do have 50 is less than 100. And in total, one statement false or true, that adds together to be true. This entire statement is true. Inside here, we say fill set to green, that number right down the middle, RGB. And so that's where we see the green answer pop up here. And that means we also get to skip altogether. We can ignore the else statements. And that tells us the ellipse here finally is going to go and be green. So congrats to you guys for getting that. So I think I'm going to go and quickly skip over this exercise here, because this one here is basically an extension of that quick question we were just asking. Basically, you use if statements to go and paint them in every single corner. But now I'm going to go and just show off one last little thing here, how to go and do some mouse clicking. Because this is a rather fun feature. We don't have clicking directly, but we do have the ability to detect whether or not you're pressing down on your mouse, which for sure I see light bulbs pinging off in some people's heads on some cool things you can go and do with that. The simple one I'm going to choose right now. Let's go and say, let's go and set this link to be red if it is down here. I'll go and explain the code all in 1 second. Set to red, and we'll keep it to green. And instead of relying on the position here, we're just going to use if mouse press, and pay attention to the capitalization. It is mouse and then capitalized P for pressed, and then it's all shoved together into a single word. When we go and run this code, we got the thread here, and then we go and click it, and it goes and changes to green. So as a rather convenient thing, you can go and make your own red light, green light game now and go scare the heck out of some people on your mouse click command. And let's see, I think the other example here, we just popped in some text in here, but virtually this should be an extension of basically the exact same thing. This background of 0 is impossible to read, so I'm going to change it to white. Sorry for everyone's eyes. Let's just go and add in some text here. So I am going to go and add text. Is going to be mouse is pressed. And I believe I'm just going to go and set the fill to be black, black text, and then green circle, fill 0, black text again, text, oops, mouse not pressed. And oh my gosh, I'm being lazy here. I'm not paying attention that you actually need some coordinates in here to make this all make sense. So we'll go and say maybe 100 across and 300 down. That should be good. Wow, what was that? And I'm just going to copy these coordinates here and paste them down here. And we'll run that. And mouse is not pressed. Mouse is pressed. Mouse not pressed. Mouse is pressed. So have fun making a red light, green light game out of that. Fantastic. I think I'm almost wrapping up on all my teaching content here. I'm just going to go and mention one of the things that we are offering is that if you are able to show up for 6 out of our 8 sessions here, we are going to go and give you a certificate, proof that you have joined our Schulich Ignite program. And we do have a gala that comes up later, but I'm going to go worry about that in a couple of weeks. Anyways, if you got questions about your submissions, I know we are a little bit slow to go and mark things, especially when you guys, or when we give you guys twice as many tasks as some people do. sometimes the assignment marks do show up a little bit slower than others. So if you're checking out that leaderboard and trying to figure out if who's ranking first, who gets those Amazon gift cards, don't sweat those details about it. We will make sure that those all get sorted out. Your mentors can also go and help out. Go ahead and ask some questions if you got anything about that. Anyway, with that, let's go and get jumping into some bug buster exercises. So these are going to be due next Monday. If you take a look here, this one should look familiar, but the only thing is it's bouncing backwards. And this one here takes advantage of that mouse is pressed. And I'm going to leave you guys to imagine how to do that. For those of you guys who are getting a little bit bored, I do recommend these challenges here. No points associated with it, but I think that they're pretty darn fun to try out all the same here. Yeah, this one I think is like simulating pool. And you guys actually have the power to go and build your own Pong game from scratch. That's what this one shows off right here. So if you guys are feeling rather inspired, try them out. Let me see what you guys can do. And with that, let's go to our breakout rooms. And we have good 30 minutes to work on these today. Welcome back, folks. It looks like we got everybody all shuffling in here. And we are just wrapping up our sessions. And I hope that you guys appreciated that time that we got to work on today's sessions. So I do know that exercise number 1 here, getting the ball to bounce back and forth is always a very tricky thing. And sometimes I see students are struggling with that. If you're struggling, don't be afraid to go and ask on Discord, and we will be happy to help out, even if it is between sessions. Excuse me. I will give you a hint here that you can use plus equals with a negative number, and you can get some pretty cool effects with that. Other than that, I believe that that wraps up on all my slides here. But what I did want to go and say is thank you to you guys. And what I should have been doing last week, because I forgot about it, but I'll do it this time, is making sure that we actually just get a quick follow-up poll. How do you guys feel about today's session? What are your thoughts? Let's answer on that. Once you finish that, feel free to take off, and I'll see you guys on Thursday. Oops, cannot see the poll yet. Oh, Rajpreet, are you able to help me out with that?
Sorry, yeah, I just I had some Zoom difficulties, but I'm just going to.
Oops. All right, let's try that again. Sorry about that, folks. There we go.
Okay,
Let's
it should
get
be
that
up
poll
now.
open.
So, all right.
Sorry, so I have a question about Discord, and I don't think I really resolved the issue.
What's up, Daniel?
So there's an HCAPTCHA test to keep out spam from Discord and like bots.
Oh, yeah.
So I've tried to do the HCAPTCHA test multiple times, and I'm getting it right. It's not working. So then I tried going on incognito mode on Chrome and a bunch of different things, and it's not working still. I'm not really sure what to do.
I have actually never heard of an issue like that before. Thanks for bringing that up. Yeah, those are tricky because there's actually probably an AI hidden behind the scenes trying to decide whether or not you're a robot. And those things can get tricky with those. Yeah, you can try also clearing your cookies. That's another approach you can try. You might also have to be patient. Wait 24 hours before you do it, and try not to spam it, because if you spam it constantly wrong, that tells Discord that you are a bot, even when it's just a human who's rather frustrated instead.
And then it locks you out and says, come back later or something like that.
Basically. Welcome to the world of fighting bots. Fun fact, there are some very cool AIs behind the scene that click the button to say, I'm not a robot. That is all AI handled, but that's not the issue here.
Isn't it like illegal to like be able to say, click, I'm not a robot or something like that? Like they make it some sort of law or something? Or am I mistaken?
Oh, interesting. I've actually never heard of that before. If you find a news article pointing me towards that, I'd love to read about that.
I mean that would be smart if they made it like, I don't know, like a fine or something if your robot did that or whatever.
Oh, no,
I don't know.
that might be a thing, but the way they work, actually, they use AI to detect whether or not it looks like a human who's clicking the button, because they actually track your mouse position, they track your response time,
Oh yeah.
they track where you click specifically on the box. A lot of little details like that, which surprisingly enough, only humans can do very well. And robots look very, very bad at impersonating humans.
There's actually
Very
bots
strange
that
thing.
are like
That's really
programmed
cool.
to pass that part of the test. Like they just specifically programmed to click like a
Yeah.
human.
Unfortunately, that's true. Robots can defeat the system still. It's not perfect yet.
AI to fight AI, right? Like that's how it's always gonna be.
It always will be that. Anywho, I do realize I'm running a little over time on this little extra discussion. Daniel, you can also email us as well if you have any questions. And if you're still getting stuck trying to contact us on Discord, then yeah, reach out, email to your mentor or email to us, and we'll figure out another way we can help you out on that. Thanks for letting us know.
Okay, thank you. Bye.
Take care, guys.
All right, I think that should be all of the mentors.